retirement, we very often see people totally retired mentally also. But his optimism is highly inspiring. And today we are talking about the space business. Today we are talking about a detailed constellation. We are talking about completion of satellite design, earth stations, everything. The start was from Dr. Hegde's inspiration. I took up this mission because Hegde told, I am there, you can go ahead. So with that few words, I request Hegde to take up. Thank you, sir. You can go ahead.
Thank you, Abhimanyu ji, and for such a elaborate introduction. But one sentence you told is very true. Yes, I'm fortunate to be Abhimanyu's friend, the ever energetic, ever optimistic, full of ideas. And it is equally my privilege to be his friend. So this interaction of mine with your team, the team put together by Janu, was rather long overdue. Due to certain difficulties at my place, it couldn't happen. Even now, I'm in a bit of mess. So today, yesterday when Abhimanyu ji asked me, could we make it tomorrow? Can we make it tomorrow? I said, yes, we will make it. But deliberately, I have not put any slides together because we always, we ISRO people, whenever we went, wherever we went, we have the tradition of coming under a lot of criticism because we show hundreds of slides, and which takes away the eye-to-eye contact, interaction. And I am not talking something which is complicated, great, or whatever. I am just trying to go down my own memory lane and try to see how applications developed in this country. Basically, along with applications, it is also the applications-driven technology which progressed. We are all aware that, when we talk of the milestones in the global space arena, man tried to access space and it became visible in 1957 when Russia launched Sputnik. Now, 1969 became all the more significant because USA achieved Apollo 11 mission, there was moon landing. But the real commercial space era came in when US enacted space policy in 1990s. Okay, so in 1990s, one great thing happened that US and Russia agreed to end the Cold War and also cooperate in space exploration. And that is actually the beginning of new space or the commercial era in the space program globally. Now, what is really involved in space activities? See, we have to have access to space. We have to somehow get into space that is above, a level where aircrafts go. So then we have to put some observational tool in space that is lifting heavy to small satellites or payloads. Then comes taking imagery from Earth. Basically, we started taking images, pictures, and processing those pictures, value addition, services. Then came the telecommunications with satellite constellations or whatever, manufacturing, construction in space, space tourism, mining of asteroids. Today when we talk of gamut of space activities, these are all the things we talk about. That is, everything has to go together. Access, obtaining imagery, building up communication capabilities, having a lot of satellites for observation as well as communication in constellations. And, if you see at the International Space Station today, it is not lifted once. So basically, constructing in space, either by men or by robotic efforts, okay, so where Janu is very much into. Then people talk of mining of asteroids, harnessing energy, then scientific research as well as brokerage, and space tourism. You know, you must have seen last week a Japanese billionaire went with his cameraman as a tourist. He took a lot of pictures. You know, he went up in Soyuz, came back in Soyuz, and he is going to be the first commercial traveler to moon on Falcon 9 sometime in 23 or 24. Interestingly, people have tried using space also for funeral services. You know, instead of immersing the ash in Ganges or somewhere, people want to leave the ashes in space. So, education with an enterprise in space, developing online education programs, new space companies. I mean, hundreds of things we can talk about. But really, if you talk of the value chain of space, we can say broadly, you can categorize satellite manufacturing, then launch those satellites, then develop and roll out space based services. Then that is not enough. Further add value and value added services. Finally, the benefit of space should reach the consumers, every citizen, every human being on earth. That is the whole effort today. So everyone comes into picture in the supply chain, manufacturer, launch operators, satellite operators, service providers, consumers, everybody. In this whole game, as much as satellites and launching them are important, manufacturing, launching them are important, ground segment is also equally important. See, whether you talk of global navigation satellite system or satellite enabled smartphones or broadband, satellite radio, television, whatever you call. But in the whole value chain of space commerce or space activities, the upstream activity, which we say satellite manufacturing and satellite launch services, makes only 5 to 10% of the market size. So we must understand what is most important is, or equally important is, the downstream activities. You know, depending on the type of satellite you build, where you launch, at what altitude you launch, what inclination you launch, with what payload you launch, the downstream activity for that particular venture makes 90 to 95% of the total market size. That is where I talk to Abhimanyu. I would rather talk more about what kind of downstream activities are happening in India and also taking reference to globally. I thought I will talk more extemporally this time. I can also interact with you in the coming days more formally. So, if you see the 2020 global satellite industry findings, because it is all same, because developed nations have gone more towards industrializing space activities. We have seen an ingest of lot of low cost satellites, smaller satellites, more powerful satellites. Launching is becoming more affordable. Satellite services are growing and helping increasing in productivity, developing newer capabilities, contributing to economic growth, make the world much safer, secure, sustainable. So and so also, I mean, the ground systems have been playing a large role. See, in 2020, you may be aware of the government space budgets. It is more than 100 billion, and satellite services about 117 billion, and ground equipment about 135 billion, and others are all small. So, really, where the effort goes, money goes, if you talk of employment creation, if you talk of more and more large number of systems, you know, a handheld gadget too, whatever, it happens on the ground actually. So, if you just take the satellite services, say for communication, if you see at the 2020 figures, in fact 21 figures should be coming out anytime by December or so. Television industry globally takes about 88 to 90 billion, radio broadcasting about 6 billion plus, broadband is about 3 billion, fixed satellite services, that is VSATs, whether it is on land or ocean or wherever, is about 15 to 16 billion. Mobile brings about 2 billion. Remote sensing, just under 3 billion. Okay. So satellite manufacturing, if you see in this whole game, it's about 12 to 13 billion, though more number of satellites are going up. Launch industry is about 5.5 billion. So ground equipment is about 135 billion. So I have to really appreciate what Janyutech with or for their principals or partners, whatever you are trying to do, is an extremely commendable thinking. I must compliment that all of you youngsters and enthusiastic people who have joined hands with this venture, which Abhimanyu has explained to me vividly. It thinks of the total system. I mean, satellite manufacturing to launching to receiving data, processing data, and ultimately rolling out services to the benefit of every common man. And you may be aware that, operational satellites are also very much on the increase. By 2020, there were about 4,000 scientific satellites, not 4,000. If you total about 4,000 satellites, and from 2010 to 2020, the number of satellites have grown about three times, three and a half times, hardly 1,000 to 3,500 satellites which were in operation. I will not get into these figures because these are very, very much available in the public domain. I mean, in the coming days or one of these days, I can share, or you yourself are, I'm sure, quite aware of these statistics, which, the Bryce space industry report, which comes year after year. But one thing which is remarkable is the ingest of small satellites. See, up to about 2008, we had not seen so much of small satellites invading the space arena globally. So we were always talking of, heavy Earth observation satellites, some heavy geostationary communication satellites, or the GPS navigation constellation, and the Galileo never took off. Russia went for GNSS, China went for video. So while all these things were happening, now suddenly it looks that everything is being swallowed by the tech entrepreneurs and the newcomers who just made the small satellite constellations a great reality. And sadly, we, India, have so far missed it, badly missed it. Okay. So something has definitely, I mean, don't quote me, something has definitely gone a bit wrong in our planning. So whatever it is, there are government-owned small satellites, private-owned small satellites giving every kind of service. So that again, I mean, it's a public domain info. I will not, I mean, if required, we can always come back. Another thing which is badly demystifying is, if you see carefully, some 40 different companies started building small launch vehicles. So the idea was, for launching small satellites, you need small launchers. Completely, it's getting demystified because one or two small satellites or small satellite in small number are good only to put some scientific or experimental payload, while the operational small satellites go in constellation. So small satellites have started preferring, I mean, those small satellites who want to go in constellation have started preferring large vehicles. Like instead of pushing, you see, when I was CMD Antrix, I was so proud that, we signed contract and 104 satellites we are going to launch together. So wherever there is space in the payload deck, satellites were rather pasted or stuck or fastened with a release mechanism. But today dispensers have come in. You put some 30 odd in one dispenser and throw the dispenser out. Of course, dispenser becomes a debris. So, I mean, lots of changes are happening in the last 10 to 12 years, which is just impossible to believe. And I mean, it's pretty amazing for us, because I can say that I am probably belonging to generation 1A of Indian space program, because the first batch of people who joined space joined around 70 or 72, whereas I joined in 75. But that was the era when applications began. So I thought, let me recapitulate something about applications as I have seen. So basically, I am not an engineer. I am a geologist, because space has really space for people from all backgrounds.
Okay.
So I started with Earth observation in my own way, and let me elaborate that when it comes to uh, see. Basically, I asked Abhimanyuji whether I can talk a bit about Indian space program, because what has happened is we are on a slightly low in the current, because if you, as you have seen, whether blame it on pandemic, blame it on whatever, 2021 we had just two launches. One was for Amazon 1 with a few small satellites of our own. Amazon 1 was a commercial payload, which was very much negotiated with when I was still in active service. And Brazil had started a remote sensing program, both building launch vehicle and satellite when we started. But they had lagged far, far, far behind, and finally came out with Amazon 1, which we understand is working well, a 4-band multispectral camera with Earth observation payload. And the other one we launched was an imaging satellite at GEO, which unfortunately failed. So having hit a bad year, and just not to feel low that we are low, we still remain to be one of the 6 major spacefaring nations in the world. But Indian space program, if you see, it started in 1962. See, just 7 years after man tried accessing space with the launch of Sputnik, a sounding rocket flew from Tumba. You would have seen pictures, the nose cone of the rocket being carried on a bicycle, and people sitting on the ground with banyans, and because sultry weather, and assembling a small rocket, and the Nike Apache rocket being carried, on bicycle, bullock cart. I mean, all kinds of pictures we have seen in public domain. So, Vikram Sarabhai, when he saw that space technology has got a lot to do for this country, and he really, really initiated. So subsequently, we ended up dedicating our Tumba Equatorial Rocket Launching Station to United Nations. I mean, any country can come and launch a sounding rocket because it is close to magnetic equator. So the our space program was born in a church actually in Tumba, which is now a museum, which is in the early 60s. Okay, but today we grew into a big program with space centers spread all across the country, and we have many centers under ISRO, under the government, and recently a new center for human space flight also has come up. We still have on paper both Antrix and NSIL, two PSUs. We have a number of public sector enterprise. We are sorry, grant in aid agencies like Physical Research Lab, NARL, Northeastern Space Application Center, and all that. So, Department of Space is the government department, which is directly under Prime Minister, under which ISRO is there. So ISRO has many centers. ISRO has few grant in aid agencies. And under Department of Space, you have two public sector enterprises, Antrix and SIL. And the apex policy making body for us is Space Commission. Space Commission is chaired by Secretary Space. It has members from academia, industry, bureaucracy, and also, of course, little of politics. Ministers are there, and Prime Minister is heading. So what happened is, since space technology involved a lot of development, obviously we lived under the shelter of taxpayers' money, government funding. So, but then how Indian space program became a self-reliant indigenous program driven by the national development goals is a really, it's a miracle actually. Because basically, when we became independent, we had to inherit a lot of things from the earlier regime, and India had a lot of issues. So I think 1952 or so, Planning Commission had come into force. If I'm right, I can't tell the exact date, but then for completely our developmental activities of all sectors were uh, aligned with the goals of national development. While the planning was holistic, the sectoral allocation by the government decided what each sector will do, what each priority will do. I mean, hats off to our the visionaries in the space domain. They said we will develop imaging satellite, we will develop communication satellite, we will develop our own rocket. Of course, we also learned a lot by sharing, borrowing, cooperating with foreign countries, developed countries. For example, we had a satellite instructional television experiment called SITE, where about 2,000 villages, the social research guys understood the issues of development. So the Space Department people, through our development education communication unit based at Ahmedabad, made programs relevant to addressing those issues in rural areas. And it was such a huge effort that we had to borrow a satellite from US and broadcast, villages without electricity, villages without any other connectivity. You have to work on batteries, you have to have battery chargers, you have to transmit some 2 hours per day. It is actually the largest social experiment ever conducted in the world using satellite, which happened in India through a borrowed satellite, and that showcased the need of communication satellites for India. So India embarked on building INSAT 1A series of satellites. So all the 4 satellites were built at Ford Aerospace in Palo Alto, California, USA, where our teams worked jointly with them. So basically, the communications program in India started with addressing the rural needs through a borrowed satellite. So also means I can go on telling a lot of stories. So also the imaging or remote sensing, because our planners realized very early that it is important to address, say, agriculture. The first ever experiment using multispectral airborne data or infrared airborne data was in Kerala by Prof. Pisharotti and his team to identify the coconut root wilt disease. So agriculture still remains to be a priority, and today we do crop acreage and production estimation for the country, both for Kharif and Rabi season, that is the regular southwest monsoon season, northeast monsoon season, and we also inventory the summer crops separately. Okay, so that is how slowly as we developed the Indian space program could distinctly display we have one component which is space infrastructure. See, our space infrastructure today comprises of Earth observation satellites. Okay, we have more than 10 operating now. A constellation for navigation, the Indian Regional Navigation Satellite System. I mean, last 1 week or 10 days, it is too much in news because India has signed agreement with Oppo, and Oppo is a company which we shouldn't have. You know, you must have read in newspaper.
Yeah. Yes.
Yeah, I mean, contemporary. I'm taking all this reference to make the topic light because it's a Saturday and Christmas Eve and all that, Christmas Day. And we also have a component of planetary exploration. We had Chandrayaan 1 and Chandrayaan 2. Orbiter still working, but lander failed. We have a Mars mission, which was supposed to live for 6 months. It is still living and made of all quartz components. Huh? Abhimanyu is aware. So our space infrastructure is rather holistic today. And we have space applications, which is actually the backbone. See, if we don't develop or pose so much of applications demand, we can't invest in infrastructure. So we have Earth observation applications, communication application, navigation, and everything we are using synergistically. And we have a variety of national level projects, I will tell you as we move along. We have also a large number of projects for environmental monitoring, monitoring land, ocean, atmosphere. And we have the specifically coming to natural resources management, we have disaster risk reduction as a major thing. See, you may be aware that after the Rio summit in early 90s, United Nations wanted everybody to adopt sustainable development practices. I mean, while we exploit the resources today, we should also ensure that we leave enough for the generations to come, and whatever we do on earth should be sustainable. I mean, lots of this is a topic from probably 1990 onwards till today, so last 30 years. So the Rio summit made 21 agenda items. Space and agenda 21 was a big talked about topic. I mean, 21 agenda points. Subsequently, it got reoriented to 9 goals, which again, almost entire world accepted when Rio plus 10 in 2000 was discussed in New York. That is Millennium Development Goals, they said MDGs, which you may be aware. I mean, these are the keywords. You can always make a search and find out what it is. But of most recent, what came in is after 2010, 17 Sustainable Development Goals or SDGs. So you may be aware in 2014, when the new government came in, the NDA, or especially after Prime Minister Modi ji took over, Planning Commission was abolished. Instead, Niti Aayog came into place as the apex for accelerating developmental activities in the country holistically. So they circulated to all the government departments to reorient the programs as per the SDGs, Sustainable Development Goals. So if you can go and see Niti Aayog's plan, perspective plan, you will find that there is a blue covered book which exhaustively gives the guidelines given by the government, which is in vogue today, that all the departments, whether it is uh, Rural Development Ministry, whether it is railways, whether it is urban, whether it is space, all departments have reoriented their programs to fall in line with the Sustainable Development Goals. It is not only in India, most of the developing world is has reoriented their activities because that is what is found feasible. I mean, global consensus on this. So, in that, there is also a huge component of capacity building, human resource development. So, in our space program, it's an important segment again. HR development, indigenization, building up technical infrastructure, international cooperation, involvement of industry and academia, the capacity building segment. Then, of course, space transportation. You have PSLV, GSLV, SSLV is coming up, and reusable launch vehicle, human space flight, all are in developing stages. And to repeat, our space activities today comprise of space infrastructure, space applications, natural resources management with specific focus on disaster risk reduction and infrastructure development, capacity building, and space transportation. And we are all aware that after the Kobe earthquake, the disaster risk reduction also became a mainframe activity, and the sustainable, it became a part of overall sustainable development goals. Basically, the Sendai framework as you call, because a huge global summit was held in Sendai, Japan after Kobe earthquake. So they thought that there cannot be exclusive disaster management segment anywhere. It has to be mainstreamed with the developmental activity. Now, if I have to tell you one example of disaster risk reduction, or maybe as I move along, I will tell you, because how we, you must have heard about the NDMA, National Disaster Management Authority, National Disaster Reduction Force, NDRF, and how do they do incident commanding? How do they drop a WLL VSAT or a Wi-Fi hotspot in disaster areas? See, sometimes when disaster strikes, say an earthquake, say our own Kutch earthquake, communications is gone, electricity is gone, everything is gone, and people are below the debris of multi-story buildings. There is no inventory where earth movers are available, where cranes are available, how to remove debris. You can hear people shouting, but you can't lift the debris and pull a man out. So, strong database, in situ communication, supported by satellite. So these are some of the things I would like to highlight. So, basically, my compliments to all of you to have got into this new venture. And probably, these days things go very fast, and one day you will all be very happy seeing the fruits of your labor reaching a common man. So, uh, now, one by one, segment wise, if you see the growth path of satellite communication in India, as I told you, 1975, we borrowed a satellite Symphony from USA and conducted satellite instructional television experiment in 2000 villages in part of Karnataka, Madhya Pradesh, and some backward areas. Then came the birth of INSAT series 82 to 1990, which was completely customized for India's domestic needs. We addressed telecom, broadcast, and meteorology, and and we also made the satellites multi-purpose, introducing a meteorological payload. Because once a satellite sits in geostationary, it sees one third of the globe. If you have an imaging radiometer or an imager on top, you can see approaching tropical cyclones, approaching cloud masses, and every half an hour you can take a picture. So why I am stressing this is we quickly started using the space capabilities to meet India's needs because we are a tropical country close to equator, much affected by tropical cyclones. So we understood that as early as 1980s. Now we should appreciate the way we have progressed or the world has progressed. The first ever access to space was in 1957 by Russia, and today we are only in 2021. I mean, space program, the way it has developed globally, I mean, it is not even as old as me, okay? It's a young program. So then came the INSAT 2 series. So we decided, I mean, India decided to build satellites indigenously. So that required creation of a lot of new facilities for building, manufacturing, testing, and introduction of VSAT communication and cable TV came in 1991 to 2000 time frame. I still remember 1975 when I joined the remote sensing segment. Basically, that time we had no satellite. When I joined, we had a small three-seater Beaver aircraft. So I had to undergo special training because the pilot said they can fly, but they can't navigate. So I've flown nearly 250 hours with a three-frequency electromagnetic system, a virion proton precision magnetometer, and a gamma ray spectrometer, almost all over the mineral belts in this country. So that was a unique experience. Then we started using airborne scanner, 11 channel Bendix multispectral scanner, then airborne thematic mapper, Dedulus ATM we call. Then came aerial photography, then came this. So really, I had a good opportunity to get into hands-on into how we really progressed. So from 2000 to 2010, we did further capacity augmentation. That is, we made three variants of our INSAT satellites, 1 ton, 2 ton, and 3 ton category. And DTH communication came in India in KU band. And we also got into exclusive meteorological missions. Say 82 to 90, we just launched 4 satellites geostationary with about 1.2 to 2 ton class of satellites built by Ford Aerospace. 91 to 2000, we just launched 6 communication satellites. 2001 to 2010, we launched 14 satellites. Okay. Then came in the high power satellites with unfurlable antenna, spot beams in Ka band and all. So 2011 to 2019, so our satellites became 17 plus actually. So with this kind of capacity augmentation, we have something like 220 transponders of 36 megahertz each today. giving us a good bit of bandwidth, but that is not good enough. We have also leased about 90 to 95 transponders of 36 megahertz uh, from foreign satellite operators. So today, about 150 out of 224, 220, about 70 satellites are not in commercial use. They are serving strategic sector. About 150, 55 transponders of our own from INSAT GSAT and about 95 borrowed satellites today are in commercial use in India, which is, of course, grossly inadequate. So, we are also soon going to have about 300 gigabits of high throughput capacity. But as of today, we have about 30 gigabits up. About 15 are into use in Andaman Nicobar Islands and border areas in the north. Mostly it is put for governmental use and hope it would be soon for rural connectivity. But the whole equation is going to change with respect to communication because you have heard of Starlink constellation, OneWeb constellation, and the O3B having been bought by SES Global, Viasat is there, and I mean so many people, and very soon we will find all of you also becoming part of this new revolution, bringing in higher capacity. But globally today, India is seen as the largest customer of bandwidth with 760 million, yes, 760 million people being communication savvy, and IoT is yet to catch up. So the global SATCOM operators see India as the largest market, and the second largest market is US, though there is only 400 plus million population, 400 million plus population. Of course, third is West Asia, as they see. So, I mean, surprisingly, you will also, I'm sure, be encouraged to know that today, I think the total bandwidth capacity from space available globally is about 6 terabytes. And by turn of the decade, that is by 2030 or 2032 or something, it is expected to go up by 19 times. So about 100 terabytes is expected to be the global demand as against the 6 terabytes we have today. So I think this is the kind of analysis on which, uh, the whole constellations are being driven actually. Now, if you see the SATCOM services which we have operationalized in our country, we have TV broadcasting, direct to home DTH, we have trunk routes, we have VSAT connectivity, we have business communications, I mean, at enterprise level, we have radio networking, we have disaster warning system, we have tele-education, telemedicine, village resource centers, I mean, village kiosks, and also the mobile satellite services. You just name it, we have. So, in fact, I'm sure that all of you know that more than 200,000 or 2 lakh VSAT terminals take care of all the ATMs today. All the ATMs is through satellites today. Cellular backhaul complementing terrestrial network. There are about 2.75 lakh VSAT terminals. And all the oil and gas terminals offshore are connected with satellites. And of most recent, India has also cleared the in-flight connectivity. You must have heard that the Inmarsat, which started mostly for maritime connectivity, because ships in the ocean had no means of really connecting with the mainland all the time. So the Inmarsat came to their help. So now the same Inmarsat modified their capacity to connect to the aviation or the aviation fleet also. And till recent, you must have, or even today, it must be the scenario. Most of the international carriers which overfly India, once they enter Indian airspace, they shut off actually connectivity. And a business traveler goes mad that, his connectivity is off because we all want to be connected all the time, either with our work or home or whatever. So, India is the second largest television market and the largest DTH market in the world by number of subscribers. You see, India has nearly 900 television channels, okay, which started really in 1982 with Insat 1B. I remember in Delhi, I used to be a paying guest at Delhi IIT. So we used to all flock before the Western TV, black and white, and basically to see Salma Sultan reading the news or Tejeshwar Singh reading the news. I mean, see, we have come far. I mean, today we have 24 bar 7, so many channels, we don't feel it all. Today, nearly 200 million households have televisions. There were 7 DTH operators in India. Now there are 5 actually. And so many. I mean, say by 2003, 2004, we were just catering to all this TV channel with 5 transponders. But today we are just unable to cater to them even with 100, 150. So if you see the key trends of applications in SATCOM services in India or anywhere else, broadband has become the major driver. Probably soon DTH may go off. Everybody may like to drop a broadband connectivity to home so that you say television, you say internet browsing, I mean IPTV, mobile, and various gadgets connected. So, I am, as Abhimanyuji told, I am such an optimistic person because I just happened to move into an apartment from an independent house. When the question of putting the fans and air conditioners came, I have put the Alexa compatible fans. And this, because I feel one of these days, really, these Orient fans come with
You have to live for another 30 years, no, sir, as per schedule.
he told me, I don't know how long I will live. And people laughed at me. I said, you are crazy. But, when it's available, better use. I mean, so really, a couple of months ago, I started furnishing. I put AC units and fans, which are Alexa compatible. So, that is a kind of optimism. Probably I am one of the least because, we are always driven by economy. So, but still, that is the way we look for. So, broadband, cellular backhauling, in-flight connectivity, Internet of Things are driving the communication trends today, where you people are into. Now, high throughput satellites are planned globally at LEO as well as MEO, low Earth and medium Earth orbits. And basically, these constellations are completely changing the economics of space and supporting consumer based applications. You see, today, if you say, I will just give you bandwidth, how many gigabits, how many megabits, this much is the charge for 1 megabit, and probably that will all go. Lot of apps have to come, lot of customized services have to come. So TV broadcasting, DTH market has grown substantially, but it will face or it is already facing competition from OTT, IPTV, and terrestrial cable services, which is going to be true in India as well, because that is what Reliance talks about, and I'm very, very sure even your enterprise, Janu with your partner or principal, this is what even you are going to do. TV, DTH will remain the key of fixed satellite service industry to wide coverage and specific orbital slot requirement. It will not go overnight in India at least. So there are also lots of new technologies with respect to data compression, optimizing the bandwidth usage, and whereas the television use will penetrate the HD, UHD, 4K TV channels are adding bandwidth requirements, but those who were probably loading 15 TV channels with one 36 megahertz transponder or seven to eight channels are today loading about 15 channels. So if somebody has got 12 or 24 transponders in KU, it's a huge resource. But then soon it will be IPTV. And I'm very sure, as far as a customer, a consumer, eventually I will not know whether I have a dish on the top of my terrace, whether I'm getting television channels from DTH or broadband, whatever, because ultimately communication will be a technology which will be neutral to customer. Customer will not know. You see, a concrete mixer or an auto rickshaw driver, when he puts on Google Map and drives, really he doesn't know how Google Map works and where from it connects. He doesn't know. It is neutral to him. Now, same way, the applications with respect to Earth observation. See, we started with airborne data in 1970s. I told you about the coconut root wilt disease. Yeah, if I am running over time, you please tell me. I'm telling more as a story actually.
Yeah. Sir,
Uh,
I felt that we can allow the youngsters to ask some questions because it's a very rare opportunity for them to talk to you.
No, what we do is as we move along, we will have more formal interactions also where I can come
Yes,
back to you with more slides, whatever. And today
yes, yes.
maybe in another 10 minutes we close because we are
No
nearing
issues.
4:25.
No
Then we
issues.
can
No
ask,
issues.
they can ask
Yeah.
questions, no?
Yes, sir. Yes. Yes, sir. Go ahead, sir. Go
So,
ahead. Sir.
yeah, then we started doing aerial photography using a Hasselblad camera. Then 1980s, we got into experimental satellites. Bhaskara 1 carried just one transponder, 19.35 to 22.35. And Bhaskara 2, then TV camera, then operational satellites we got into only during 1990, the Indian remote sensing satellite series. And we also got a handle on the data transfer rates, 100 kbps to up to 3.5 gbps. In Cartosat 3, we went into Ka-band network and data transmission S to X to Ka-band. And by 2010, we have the knowledge of contemporary sensors, contemporary data reception, processing, distribution, everything. But again, we failed in having appropriate constellations. Okay. So I will not again go much into it. So we went into IRS series, Carto series, and to make the whole effort more user friendly or support development in a bigger way, we have uh, got many web-based information services, web portals for meteorological data reception, web portal for Earth observation data reception, and I mean too many things because I mean if you go to ISRO website, you will see uh, a lot of applications. I mean, so we are today one country as one of the six major spacefaring nations. We have addressed almost every facet of space technology and its applications, but still it's so huge and growing exponentially. So we have to catch up with a lot of things. But one good thing that has happened is we have also got, though looking auxiliary as a requirement with respect to development of polymers, chemicals, system engineering, software, alloys, composites, electronics. I mean, you just name it, developing propulsion technology. So many things we have tried to do. So, I mean, the demand caused us some kind of pull, I mean, technology pull. So when we tried to match, some flow started. And now, definitely, I will not say that we have achieved any sustainability because it is the right time that government thought we must bring in private sector as a partner in all space sector activities. So they have put in place in space, which is the body for enacting appropriate regulations and promoting industry. And
That's it. That's
NSIL would be an aggregator or facilitator.
that's it.
And we are very sure that soon the taboo will go away and a lot of entrepreneurs. And let me also compliment Abhimanyu and his team that you are probably the one uh, who have put in a huge end-to-end canvas for yourself. I mean,
We are trying our best, sir, with all your
because
wishes and
you are,
support.
you are not a startup. You are a company with a different vision. I'm not trying to praise you or whatever,
Yes,
because
thank
most
you.
of the other
Thank you, sir.
startups are having just one small element trying to focus, whereas you are trying to draw an end-to-end canvas, and
Thank you.
you have
Thank
put
you.
together a very, very impressive team. And I wish, I really wish, all well for your vision and your enthusiasm, zeal, whatever. And definitely, it's a great privilege for me to be interacting with you. And in the
That's
coming days, definitely it would be my honor to interact
yeah.
more with you.
Our team would like to physically meet you also. Once things are normal, I'll bring them to Bangalore, or I'll invite you to Bombay soon. Right,
No
sir?
issue.
We'll have
Yeah,
a physical session also. Right, sir?
yeah, yeah. Sure. No, I
Can,
will
can I
come.
can I ask the team to ask a few questions, sir? A couple of questions. Can I accommodate?
Yeah, I mean, feel free, because if I don't know, I really don't know, because you can feel free, because I have taken all the liberty
That's it.
to make the interaction look so casual, because
That's it, sir. That's it. That's it.
because
Wishes you add some questions to ask, sir. You can ask some questions. A couple of questions. We'll try to minimize the questions. Other things we can compile and send that Hegde mail and get a reply.
yeah.
Yeah, wishes you can ask some questions.
Yeah, hi sir. Thank you so much for this webinar. I mean, I think we are at a very great sync with the James Webb Space Telescope's countdown in the background. I
Mhm.
think it is being launched at Ariane from Ariane now. Okay, so I have this question. Like you mentioned that infrastructure has to be. Is it echoing? Okay,
Yeah, yeah.
space
It's okay. It's okay.
space.
Go ahead.
So space infrastructure has to be indigenous. So, is it for some strategic reasons or what?
No, no, no. Not exactly, because we have only seen the draft policies today, where they say that it only mentions the word called NGPE, non-governmental private entity, will be allowed to own space infrastructure. Nothing like it. Because today, if say Boeing registers a company in India, Boeing India or Lockheed Martin India, they become Indian companies. See, now when it comes to communication, space will facilitate necessary approvals from the space side. Okay, this is what I have heard, the latest update that I have. I am also waiting, like everybody else, to see the final policy coming out. The the telecom services are licensed by the telecom ministry. They have already brought out the policy for the low bitrate connectivity. You must have seen it in the web. And when it comes to the uplinking or broadcast policy, they say that the landing rights are to be governed by the land, you know. It is not only true in India, because for any satellite operator, the landing rights have to be given by the host country. Now, some of the concerns our people are having, they are not telling indigenous. Definitely no. So even if any company partners with Starlink today or OneWeb today, now I don't think that should matter as long as they have registered in India or they have joint venture or partnership with some Indian company. And as Indian company, when they seek license, so that's it. I mean, though major infrastructure is built at somebody's cost, they may only say that, okay, you comply with the laws prevailing in India, rules, policies prevailing in India as far as extending services in India. So it is not exactly, we are receiving data from many foreign satellites, and for our IRS satellite, we were having nearly 40 ground stations all over the world, and 2 in China and 2 in Russia also. Even China was receiving data from us. So I don't know whether I got your question correct. It need not be indigenous, no.
Yes.
Sir,
Go ahead, Bharatji. Go ahead.
yeah, yeah. Sir, thank you for the wonderful talk. Really a privilege to hear you. Uh, Sir, in continuation to what Vishes had asked, you particularly mentioned that in the future, communication infrastructure is likely to go totally, uh, to the space from the current terrestrial one. So, in such a scenario, from a national security point of view, how serious a risk is that? That the entire communication network of uh, of the world, in fact, not only of India, but we speak from an Indian perspective, would be controlled by a couple of companies whose interests or intent is something that nobody will have control over. How serious do you think so?
Yeah, I mean, see, I honestly, I am not very competent to give you probably satisfactory answer. See, what will happen is,
Mhm,
what I told is, yes, space will have a large share in the whole communication backhauling.
mhm,
There would be terrestrial networks, there would be backhauling, there would be certainly backhauling. But again, you know what Arthur C. Clarke told, that virtually 3 satellites at geostationary orbit can communicate, make communications, reach the whole Earth anywhere to anywhere. And, that still stands as a very valid statement even today, because any terrestrial communication effort in the global context is incomplete without satellites augmenting the backhaul. So, what I mentioned is, eventually for the end user, see, for me having a mobile phone as my access to the world or anywhere, uh, how, I mean, the technology is neutral, it's in the background. I will really not know whether it is the optical fiber feeding to my router at home, which is working, or where exactly that optical fiber is backhauled with a VSAT or a satellite ground station. I don't know. Because if you see this, uh, the phased array ground terminals, which Karvalux is talking about, or the Verizon technology, or tomorrow when aviation connectivity starts working and all. See, basically, it can go anywhere. Today, if you see Karvalux, you give a web search of, on Carvalux, which Saturn Satellite Networks is talking, they say that a football-sized phased array antenna with a small solar panel can be carried to any place uh, on a motorbike, even remotest rural area, and within 30 minutes you set up, and around which about 50 nodes can work, 50 mobiles can work. In fact, Miasat of recent did a very nice experiment, because when they got into the vaccination drive uh, during the corona pandemic, and they carried a kind of a Wi-Fi hotspot to village. They dropped it, and the health workers went to each village, and online they updated all details about the guy or lady who is getting vaccinated, and there were no connectivities, no connectivities. So uh, the satellite connectivity is going to play a very, very important role. Now, the security aspect, I feel probably some appropriate firewalls, or what do you call? I think encryptions, something should prevent. You see, you may be aware that when of recent, when India had trouble in the borders, all the interactions between the headquarters in Delhi and the our own forces in the front were happening on Zoom. So now they realized it's risky, and they banned using Zoom to, you know, Zoom conferencing. So I think some solutions will be found, because I don't have the exact answer. Yes, security hazard is
Okay.
always there.
Right.
Okay. We will find someone who can throw some light also for the team to get enlightened soon. No?
I don't know actually. Let me find out. If you,
Okay.
yeah, I can tell somebody in Satcom Industry Association,
Okay, sir. Okay, sir.
because Satcom Industry Association of India has people from all kinds of, I mean, who are into satellite communication business.
Okay. Okay, sir. Okay, sir.
If anybody can throw some light, I will connect them with you
Okay, sir. Okay, sir. Thank you,
positively.
sir.
I mean, especially on the communications security or information security
Okay, sir.
in this
Okay, sir.
globalized
Okay, sir.
constellation-based
So,
SATCOM.
sir, we are touching the limits. Can we?
Can we close the call, sir? And any other questions, we'll compile and send it to you by mail, sir.
Sure, sure, sure. And
Uh, 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 Sai Hemant, you are online, sir. Sai.
Yeah, yeah. Yes, sir.
I'll introduce Sai Hemant also. Sai Hemant is a young engineer, undergraduate and postgraduate from IIT Aerospace, IIT Bombay, and we together formed this company. So I wish Sai can give you a vote of thanks. Sai.
Sure. Dr. V.S. Hegde ji, it is indeed our honor and pleasure to have had you in our Saturday talks. And I was essentially, or rather, stuck to the great detail of the length and breadth of the canvas that you were covering through your presentation. But we do understand that ultimately technology is in the background, but we have to focus on the applications and value-added services with the customers at the forefront, be it disaster management or resource planning or connectivity. So we look forward to your counseling and advice in going ahead in this direction, sir. And we wish that, as you said, we put together around 100 terabytes of bandwidth in the space, and our value additions in some of that. So thank you very much, Dr. Hegde, and everyone for being part of this wonderful evening. Thank you, sir.
Thank you so much. And it was indeed my privilege. Thank you and all the best.
Thank you, sir. Thank you.
Thank you, sir.
Yes, yes. I think Vichist has got something to say. 1 minute, please. Please hold on.
Hi, sir. I actually have one more question. It's with regards to the space debris, sir. Like since we have so many satellites coming up now, like 42,000 satellites SpaceX is saying, and then 700 plus satellites OneWeb, and then 16,000 satellites Telesat. Even we are coming up with so many satellites. And with the orbital nature of the satellites, they will eventually cross over the Indian geographical areas, Asian lands, and all those things as well. So even ISRO has come up with this new space situational awareness center, right? So I just wanted to know if what new any new regulations or something coming up from ISRO perspective to be put on upcoming satellites in
No,
terms of
actually, yeah, this is, I mean, all will have to be governed by the UN regulations. So, see, the geostationary satellites at the end of the life, they are kicked up actually. When still little fuel is left, they say
yes, sir.
that they are sent to graveyard orbit. And the Neo Leo will have to be made to re-enter and burn actually. So that is what globally there is a lot of effort. There is also an effort to scavenge some of the satellites, and it is still an area where a lot of research is going on. Deorbit sail. If you see, experiments where end of the life, the satellite will, will have something wherein a huge sail is deployed like a parachute kind. It will be folded and kept like a matchbox, but several square meters wide sail. It will introduce more drag. It will come back and it will re-enter, and en route it will get burnt actually. And there are also some missions they are trying to scavenge the satellites. I really don't know how, but when I was still working with Antrix, the Ukraine Space Agency had come with a request for us to launch 8 satellites, 4 for scavenging LEO debris, 8 for scavenging geostationary debris. So I think some solutions will emerge, but scavenging thousands and thousands of satellites will be a big job. And it will be also a hazard for launching new satellites, launchers. Today with NORAD or whatever tracking, we also have COLA, they say collision avoidance study we carry out for each of our launch vehicle missions also. Sometimes in the last minute, we will reschedule our flight liftoff time by 1 minute, 2 minutes, and things like that. So today, I mean, through uh, MOTR, that is, what is that? Medium orbiting some tracking radars, and with the help of tracking radars, with the help of NORAD data, everybody does a lot of collision avoidance studies before each launch. But this is going to be a big nuisance. I know because the space science people, the astronomers have raised strong objection that these satellites will be reflecting a lot of light, and it is a nuisance for observing space, through telescopes. So the astronomers have expressed concern. And I also read somewhere that the future Starlink satellites, will be painted with some coat. Even solar panels will be made in such a way that they won't reflect and tamper the incoming radiance from outer space for the observers on the ground. So I think this area will logically evolve into something.
Okay, okay.
Yes, sir. But sir, do you think there is any mandatory need for putting up regulations in the upcoming satellites for maybe any with regards to maybe saving up some fuel for the LEO and MEO satellites so that they can get back to the atmosphere, or some such regulations should be made mandatory for upcoming
Uh,
satellites?
at least in our space policy, draft space policy bill or whatever, such regulations are not there today. I have also not come across such regulations, Joe, though I heard somewhere the new NASA chief, Bill Nelson, telling that they want to use space sustainably. I don't think any concrete policy guidelines have been issued by any government globally. What I can do is, like anyone does, I also receive a lot of this input because in Google, several keywords you can give and you get a lot of global news several times a day. But I haven't really seen any policy being enacted by any government. But if there is anything, I will share it with Abhimanyu. But it is a tough job because at the United Nations level only, UN Outer Space Office level only, something has to happen. But people are conscious because even private people, I'm very sure, will be more conscious because Chinese want to outsmart everybody. No, if Elon Musk does, and they will at least make 10 more in their constellation. They're going very strong. So there will be a lot of nuisance up in space in the coming days. That is sure.
That's right, sir. We will soon meet, sir, for our ITU and other applications. We'll need your suggestions. I think with that we can close. Any other questions, please, Vasist, you can coordinate. Then we can come down to that. Okay.
Sure.
Right, sir. Right, sir.
Pleasure. Yeah.
Thank you, sir. Wish you a happy New Year.
Thank
Thank you, sir.
you. Merry
Thank you, sir.
Christmas. Happy New Year.
Thank you very much, sir.
Thank you. It was a great pleasure. Yeah.
Thank you, sir.